Hi, 8th and ninth grade. Are you ready for science class? Get your book out, and you need to do a lot of reading today. Now, there's not much, there are not many questions, not much work, but a lot of reading. And the reading is kind of fun reading. It's not really boring. I mean, now there's a little bit of this talking about the eye, and it's talking about how it works in each part. A little bit of that I don't know quite how to say. It's a little deeper than what I can say explain. But I found out why I wear glasses, and some of you are wearing glasses, and you know why? It's either one of the two reasons. You're either nearsighted or you're farsighted. You're either you can't see things way out there, or you can't see things way right up here. And guess what? I can see things way out there. Matter of fact, I can read the clock in the back of the room. But if you want me to read this writing right up close here without my glasses, I gotta kind of get the book out there, you know. So it's not hard to figure out what's wrong with me. Oh, we're getting ahead of the subject here. Let's talk about colors and rainbow. On 382, you have a droplet of water at the bottom of the page in figure 15.8. Now this is a little bit complex. Now just follow, okay, you have this little droplet of water and the light shines into it. It hits, reflects, no, it refracts, hits the other side, reflects, refracts again back out. And look how it twists. Look how the light goes in. Follow just one of the colors. Follow red. That's the top one there. He comes in on top. He hits. He flips around. And he refracts back out red on the bottom. Okay? Now, you say, why does it do that? Well, it's got to do with the reflecting and the refracting part. And when you put the two combined, the light shines into the water here, and it don't keep on going. Well, yeah, there'll be some that will, some of the light rays will, but a lot of that reflects back out. So he talks about it on the next page as the water enters the raindrop, and then as it is refracted, reflected, and refracted again. There you go. It's refracted, reflected, refracted. I'm on top of page 383. Actually, if you look, the same angle, no, the same side that the light shines into, it reflects back out that same side. So now, if you look at this, it brings you down to lenses. Lenses, the raindrop works like the lenses of a telescope or of a microscope or of my glasses. They bend the light rays and they bring them in. And if you keep going on page 384, you have what they have, a focal point. So if you look at the incident light rays as they come in and they refract and they bend, okay? If you do bend this one this way and this one this way, okay, if your lens is like this here, look at the 15.9 example, you see you bring it into a focal point to where it hits. That magnifies something. Or if you look at the other shape, converging lenses on 15.9 is different than 15.10, where you have diverging, converging and diverging. One focuses the light in and the other focuses the light out. It's not really hard to understand when you see how it's made. If you see how the first one is like this here, And so when light shines into it, it refracts it, and then when it comes back out, it brings it down like this. And then, of course, here, it basically just goes straight through. And that's the reason it needs to be focused on a certain point. Your eye does that, or if you have a camera and it's auto-focusing, which all cameras are auto-focusing to my knowledge, and even your phones. You take your phone, you hold them up, and it will focus, and it'll put a little box around the thing that it's focusing, or at least cameras will do that, so that if you got it on the wrong object, or if you're wanting to focus that object way back here and all of a sudden it's focusing right up here in front of your table, your desk, or whatever, that little box will go around the table and you say, oh no, I got to tilt the camera up so it focuses out there. And it will take a clearer picture. Yeah, I probably will not show you the CDs today. I may do that tomorrow for tomorrow's lesson. On 15.9 and 15.10, there is a little video clip with the CDs as well. How could you see it the other day when I showed them? Is it helpful or is it not helpful? Okay, you have one question on 15.8. On your own, you shall consider the two lenses pictured below, and then which one focus light rays closer to the lens? Okay, you have a thin one and then a fat one, and which one focuses it closest to the lens? Okay, do you want your angles to come out long and focus way out here, or do you want to come out real short and focus right in front of it? Or do you want to make them long down? You think about that and you choose A or B. So if you need to, look at your example and think about the more the lens is cut, the sharper it'll break them. Did I tell you the answer? Hope not. Now, here comes the part of the human eye. It starts on page 385 to 386. Woo! If you understand this, you are a brilliant scientist and you need to be an eye doctor. I'm sure that there are eye doctors that have studied the eye for years, and they've seen many, many different eyes of people. And so they probably understand this, and they could come teach this lesson just like clip, 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 clip. For me, I got to study and look at the picture. And 15.11 is the human eye's picture. And so we'll just take a quick look at that there. I hear about the pupil. I hear the pupil of the eye. So I got to take a little look, and I see that the pupil is the yellow, the little pale yellow part. Okay, that's the pupil. The iris is the little thing that closes over the pupil. And we say, I use these terms, the book uses them well, how it dilates. The eye will dilate. And it lets in that little iris has got two little pieces that stick over the pupil, and they're going back and forth, that if it lets in just barely any light or lets in a whole bunch of light. And that's why it is like, for illustration, if you're outside and the sun is shining bright, there's lots of light, well then that iris closes down and don't let much light into your pupil. Isn't that amazing? And then if you walk inside a room and it's dark and you can hardly see, you're kind of looking, squinting, trying to see, well, that iris opens up and lets all the available light shine into your pupil so you can see. And then we say you have cat eyes. Well, I wondered how the iris is on a cat that they can see in dark. Now that's a whole different story, so we won't go there because I don't know all the details there. Now you have another part of the light, cornea. We've talked about the cornea. You've heard of the cornea. That is the little section right in the front. That is, I would say, I would call it a lens that protects your eye. The cornea does. You have another muscle called ciliary muscle. It's up there on the top. And then, of course, in the back, you have the optic nerve that takes the information from the eye to the brain. It transfers it from here to here. It's better than a fiber optic line, okay? Yeah, you have your retina and your lenses that adjust to convey the message that your brain should receive. I thought it was interesting. Let me see here. Now look on page 387. I want to tell you that. In the first full paragraph it says, believe it or not, okay? The eye can actually change the shape of the lenses in order to keep the image in the same place, regardless of where the object is. This is accomplished when the ciliary muscle, it squeezes or expands the lens, which changes the lens's focal point. Okay, so that muscle up there can either flatten it out, can either make this thing flatter and so it bulges, or it can pull it up and make it thinner, and that makes a focal point in the front. Even if that object moves away from you or toward you, the ciliary muscle pulls or pushes your pupil to make it stay focused. That's amazing. Yeah, here we talked about the camera again. It says that the camera does that same thing, but you know, I can look around this room real fast, and I can look right here at this book, and then I can look up and I can see the bookcase in the back, and my eye just automatically, I can see back there, I can see the globe on top, and all of a sudden I can look right here and my eye just focus right down and I can read from the book. That is autofocusing. Autofocusing. And your eye does that 10 tons faster than your camera will ever do. And maybe even 100 times, I don't know. I found this interesting now, back to where I was going a little bit ago. Halfway down on 387, as you was reading that, you see what Darwin said? Darwin was the one that's been credited for all evolution and all that, how that man. And then he said, even Darwin admits that the eye is such a sophisticated work of engineering that the very idea of an eye forming by chance is preposterous. This, in his book, Origin of Species, Darwin himself sighed. Listen to what he said. To suppose that the eye, with its inimitable contrivances for adjusting the focus of different distances, for admitting different amounts of light, and for the correction of spherical and conical aberration, could have been formed by natural selection, okay, could have been made by chance, seems, I freely confess, absurd to the highest degree. He said it's craziness to think that the eye just happened to come about by chance, and that it just evolved from nothing and become this magnifying image. He said it's the highest, absurd in the highest degree. So it's the highest degree of craziness to believe that. And then it says, of course, even though Darwin admits that the whole idea of the eye forming as a result of evolution is absurd, he still chose to believe that it did. Ain't that absurd itself? In fact, he spent many pages trying to convince his reader that this absurd idea could actually work. In other words, Darwin had an enormous amount of faith in his hypothesis. When you see incredible engineering like that of an eye, it seems much more reasonable to assume that such a marvel was designed by a very intelligent designer. Okay, just accept it. It took someone brilliant, more brilliant than man, to form the eye. Yeah, we try to make cameras, but they're nowhere near the magnitude of brilliancy that the eye is. Are you kind of glad you can see? I'm kind of appreciating my eyes. Now, I think that's all I have on that part. Let's go to page 388 and look at the experiment. You can do this experiment. Matter of fact is, you must do that. It's a requirement. It's a class requirement. Okay? You must do it. You need 2 white sheets of paper without any lines on them. And you can follow the directions. It's pretty simple. You'll need a red marker. It says a red color will work, but a red marker. And you will color across. I'll let you read the instructions. You can read. And then you stare at it for a while and you move it out of the way and see what you see. You must do this one, okay? Okay? And I found this, that in your eye, it is focusing and after a while it gets tired. It gets tired of focusing, so it just assumes that it still sees the same picture. It's called optical illusion. Let's do, I'm ready to go to at the bottom of 389 it says, adding and subtracting colors. That says your eye can discern more than 16 million different colors. 16 million? I don't believe there are 16 million colors. I mean, I've seen packs of 8 crayons, colors of 8 different colors. Then I've seen packs of 16. That's pretty well, I think 16 colors. Oh no, then they got 48 colors. And I believe maybe there's 64 different colors, and I don't know how big a pack of colors you can get, all with a little bit different. And I say that's craziness. You only use 8. 8 would be plenty. Well, matter of fact, there's only 3 colors. Only 3. Of the 16 million different colors, however, they need only 3 types of cone cells to do so, with cone cells that are sensitive to only 3 basic colors. 3 colors. You can make 16 million colors. It's red, green, and blue. Red, green, and blue are your colors. Those are your 3 basic colors. And from those 3 colors, you mix them right, you can get 16 million. 16 million from 3 colors. So if you would bring these down into one color, you can get 16. How many zeros is that? Is that right? Can you see that? It's kind of pale now. 16 million colors with 3 colors. Turn your page. Okay, you call those 3 colors your additive primary colors. So look at the figure 1512. Some of you know this, I'm sure, but when you color red and green together, you mix those colors together, you get yellow. If you go green and blue together, you get cyan. If you go red and blue together, you get magneta. Did I say that right? Magneta. And if you mix the 3 together, you get white. Wow. Is that hard to believe? That if you take a green color and a red color, you can kind of make it yellow by mixing the colors together. But if you would take it and mix the paints together, red, green, and blue, you get white. Wow. Equal amount of all 3 colors results in white light. You put the same amount of each one. Then you can see how they made the 3 different colors. They put 3 parts of red plus 2 parts of green, you kind of get a brown. And 3 parts of green plus 2 parts of blue, you get a pale green. And 3, I don't know what, maybe there is a name for that, I probably don't know. 3 parts of red plus 2 parts of blue kind of gives you I don't know what you say, lavender color. Now, let me talk about how this is a little bit confusing. The next section where it talks about how colors, how that your eye perceives them. So he says, like on the screen you're looking at right now is emitting light, is shining light, and that makes your eye receive different colors. He says, remember, computer screens and television shine light into your eyes. That's a different thing when it shines light into your eyes versus when you look at the color in the book. Okay? You'll have to read how that works on the bottom of 390 up and on top of 394. Paints and dyes reflect light into your eye. This makes a dramatic difference on how colors are generated. Okay, the way colors are generated in your brain, the way you understand them is a difference whether they're shining into your eye or whether you're looking at them and then they're reflecting back up into your eye. And the difference is you say, oh, is this here shining in my eye or is this here, I'm looking at it on paper, think about it, if I turned out the lights, could I still see the color? Okay, if it was completely dark, you could still look at this screen that you're looking at and could still see it because it's shining light into your eyes. Let's go to the next one. Now, once you have your primary, we talked about red, green, and blue, now you have your subjective primary and subtractive primary colors. You have cyan, magenta, and yellow. And so now, when you mix those together on page 15.3, you can come back up with red, green, and blue. And then if you mix all those together, you get black. Now, isn't that amazing that the one, you just mix three of them together and you get white, but when you mix all the others together, you get black. Well, that kind of blows my mind. But look at your pictures over here on the side again, on 15.13. Look how near a lot of these match the original ones. This one here is very close to this one here. And this one here is very close to the middle one. Now, this one here is nowhere near to the red one. Read that, and that will, how would you say, give you a good perspective. If you were to look at this book under a good microscope, you would actually see dots of cyan, magenta, yellow, and black. That when this book was printed, only those 4 inks were used. How you like that? Cyan, magenta, yellow, and black made all the colors in this book. That's a matter of fact, all the colors you need. Yeah, I will let you work on those on your own using the flashlight lenses. So you're mixing colors. So just look back at your examples. They give you the answer. If you study your examples and you look at those questions, you got the colors right there in your examples. So for answers 15.9 and 15.10, you will find those by studying your figures 1512 and 1513. There's your answers for them. I think that's all I have. You enjoy the day, and I will come back with the study guide.